right, so we looked at the product rule, what we do when we take the derivative of a product of functions, and now we're going to take a look at what to do when we take the derivative of a quotient of functions. And one of the things we have to make sure we understand, right, dividing is always a little bit more complicated, right? If you divide two differentiable functions, their quotient will be differentiable as long as the denominator is not 0. So we do have to always add in a restriction, right? We're never allowed to divide by 0. So we can only talk about the derivative of f over g if we add in the restriction that g of x can't be 0. But this derivative rule has some very similar components to the product rule, right? We have the matching of one function with the other derivative. But the one thing you'll notice is that there's a subtract sign, right? Subtraction is not commutative, so the order does matter. There are a couple of sort of easy ways to help try to remember this. So I'll go over some of those. But let me step you through it here. You're going to take the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. That's what this description here says. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. It's a pretty long rule when you think about all these symbols, but if we reduce it down, again, take the just parentheses x part out of it, the rule becomes simplified and it's a little bit easier to remember. I also learned it this way a long time ago, and I still remember it. Low d high, high d low. Low meaning bottom, high meaning top. D high means the derivative of the top. High being top, low being bottom. D low means the derivative of the bottom. Now you still have to remember the minus, and you still have to remember the bottom squared, but that's something that stuck with me as a way to remember how to get started. There's all sorts of ways to remember it. At some point, memorizing it is important, but the hope is, again, that you do enough of these practice problems that you start to memorize it without trying. If you do struggle memorizing some of these rules, I would suggest that every time you turn a page in your notebook, you write them down, try it from memory, correct it if you need to. But if you keep writing it down page and page over and over again, then you should be okay. Now, when we go to do this derivative rule on an example like this, right, again, we have to identify the top and bottom. If we're going to use the quotient rule, we have f over g, right? So we're going to do the bottom times the derivative of the top, which is 2x, minus the top times the derivative of the bottom, which is just 1. Now, let's just say you don't feel comfortable doing the derivative of the bottom in your head. You could always just fill this in, d dx x plus 1, where this 1 over here is. And then, or you could do this off to the side, and the derivative of x plus 1 is really 1 plus 0. That's where the 1 came from, right? And then all of this is going to be over the bottom squared. Okay. Now you can't divide the x plus 1s here because this x plus 1 on the top is part of a subtraction. So for simplifying, we're going to have to distribute, right? 2x squared plus 2x minus x squared all over the bottom. There's nothing really to be gained from multiplying the bottom out, right? Because it's not going to give us anything. But we do need to do some cleaning up, simplifying, combining like terms, and factoring in the numerator. Just going to make sure this plus here looks like a plus. Right, and this would be the fully simplified derivative using the quotient rule. Again, there's the identifying part, right? Identify that it's a quotient rule, knowing the rule. Then there's the taking the derivative part, and then there's the simplifying at the end. So you'll have to keep practicing these until you can get better at them and get them consistently. All right, for this example, once again, it should hopefully stand out as a good example for the quotient rule. If we want to take, in this case, we can say f prime, right? Again, we'll do the bottom times the derivative of the top minus the top times the derivative of the bottom all over, got a little ahead of myself, all over the bottom squared. Okay, there's really not much you can do to simplify in a case like this. There's nothing you can factor out of the top. There's no like terms to combine. So in some sense, there's less work to do, which makes it easier. But sometimes when there's a bunch of stuff around and it feels like things should come together, we start to get uncomfortable leaving all this here. And people start to do things like cancel the x on the top with the x squared or other things. But that's really as good as it gets here. Again, there's the issue of simplifying. If you could simplify by dividing first, then I would do that before doing the quotient rule. The quotient rule always works. The product rule always works as long as you identify the right products and quotients. But sometimes simplifying first can avoid a product rule or a quotient rule and just make the problem in general easier. Here's another one we can do. It's very similar to the first one we did, but there's a little more going on, so the simplifying is going to be a little bit more complicated. In a case like this one, I would do the bottom, right, times the derivative of the top, and I'm going to say 2x plus 7, right, minus the top, x squared plus 7x minus 5 times the derivative of the bottom, which is 2x, all over the bottom squared. And in general, there's no point in multiplying the denominator out. Leaving it factored is going to be better. Now you are going to have to do FOIL here, right? So we'll get 2x cubed. I'll do plus 7x squared minus 6x, and then minus 21. Now you're going to have to distribute this 2x. You're also going to have to distribute this minus sign, which you can do in two separate steps, or you can try to be careful and do it all together. Minus 2x cubed. We'll say minus 14x squared. And then I see a 10x. It becomes positive 10x. All of this is over the denominator, x squared minus 3 squared. Okay, luckily for us, in this case, we have these x squared terms dividing out. I see a negative 7x squared when I put my two x squared terms together. I see a plus 4x, and then I see a minus 21, and all of this will be over the denominator, x squared minus 3 squared. Now, if you have a trinomial like this, we would want to think about factoring. Are there factors of 147 that that add to 4, and the answer would be no. So the numerator won't factor, so that's the best we can get, and that's where you would stop. But you would have to consider that. Okay. Getting to this step here, right, that requires calculus and the quotient rule. Everything else is algebra, and sometimes that is the part where things go wrong. So I think when you're checking these and working on these, if you make a mistake, first thing is make sure you did the calculus part right, then start to try to work through the algebra and make sure you didn't lose any signs or didn't make any simplifying mistakes, factored when you can, didn't factor when you can't. And hopefully these things will get easier. But it does take practice and repetition to really learn these things inside and out and get used to what the answers look like and what kind of simplifying it might take.